Water is everywhere on Earth, flowing from taps, filling oceans and falling as rain. But from space, you see its true significance. Earth's blue hue is the mark of water, the foundation of all life here. Every living thing, from microbes to whales, depends on water to survive. It's the universal solvent, enabling the chemistry of life inside every cell. Without water, life as we know it simply couldn't exist. Water shapes our world, regulating climate, carving landscapes, and sustaining ecosystems. Its unique properties make it the perfect medium for life to arise and thrive. When we search for life beyond Earth, we're really searching for water. Finding water elsewhere doesn't guarantee life, but it means the conditions might be right. The search for water is the search for habitable worlds, a second Earth. As we venture into the cosmos, we're not just looking for rocks and dust, we're seeking the miracle of water. Water is more than a resource. It's the architect of our world and the engine of biology. Appreciating water's role is the first step in our journey to the stars. Finding water on distant worlds is a high-tech detective story. We use spectroscopy, analyzing light from planets and moons, to spot water's unique chemical signature. Orbiters like Mars Reconnaissance Orbiter map hydrated minerals, revealing where water once flowed. Rovers such as Curiosity and Perseverance drill into Martian soil, heating samples to detect water vapor, giving us ground truth. Radar lets us peer beneath surfaces, bouncing radio waves to reveal hidden ice or even subsurface oceans. This is how we found evidence of a buried ocean on Europa and water ice beneath Mars' poles. Each technique gives us clues, narrowing down the most promising places to search. It's a blend of remote sensing and hands-on exploration. These methods guide our robotic explorers to the best targets. The hunt for water is a combination of clever science and cutting-edge technology. Every discovery brings us closer to understanding where life might exist. Water is the signpost in our search for life beyond Earth. The moon was once thought to be bone dry, but recent discoveries have changed everything. Hidden in the permanently shadowed craters at the lunar poles lies a reservoir of water ice, preserved in darkness for billions of years. These craters are among the coldest places in the solar system, never touched by sunlight. Missions like Lunar Prospector and L-Cross found strong evidence, hydrogen signals, and direct detection of water in impact plumes. This discovery is a game-changer for future exploration. Lunar water could be mined for drinking, growing food, and even split into hydrogen and oxygen for rocket fuel. Oxygen to breathe, hydrogen and oxygen to power rockets. The moon could become a refueling station for deeper space missions. Water on the moon transforms it from a barren rock into a vital resource hub. The next era of exploration will depend on learning to use these hidden reserves. The moon's icy shadows may hold the key to humanity's future in space. Water is turning the moon into a stepping stone to the stars. Mars was once a water world, with rivers, lakes, and possibly oceans. Ancient river valleys and delta fans show where water once flowed. Over time, Mars lost its magnetic field and atmosphere, causing most water to evaporate or freeze. Today, water is locked as ice in polar caps and beneath the surface. Landers like Phoenix have dug up this ice, and orbiters have mapped vast subsurface reserves. If melted, Mars ice could cover the planet in a global ocean. Seasonal dark streaks hint at possible briny water flows even now. Mars' lost water is a cautionary tale about planetary fragility, but also a beacon of hope. The presence of ancient water means life might once have started there. That's why we search ancient lakebeds for signs of past life. Mars ice reserves make it the most promising target for future human explorers. Local water could support long-term missions and even settlements. Mars' story is one of loss, hope, and the enduring search for life. Beyond Mars, the icy moons Europa and Enceladus are prime candidates in the search for life. Beneath Europa's fractured ice lies a vast, salty ocean, kept liquid by tidal heating from Jupiter's gravity. The churning ice and possible hydrothermal vents below could create a rich environment for life, much like Earth's deep oceans. The challenge is reaching that hidden ocean. Future missions aim to land and study the surface in detail. Enceladus, Saturn's tiny moon, offers a shortcut. Geysers near its south pole shoot water vapor and ice into space. The Cassini spacecraft flew through these plumes, detecting water, salts, and organic molecules, direct evidence of a subsurface ocean. Enceladus is literally spraying samples of its ocean into space, inviting us to study its habitability. These ocean worlds may hold more water than Earth and all the ingredients for life. Exploring them could answer one of humanity's biggest questions. Are we alone? Europa and Enceladus are the most tantalizing places to search for life beyond Earth. Their hidden oceans are waiting to be explored. The next great discoveries may come from these distant, icy moons. On the International Space Station, water is precious and every drop counts. Astronauts can't bring enough from Earth, so they recycle almost everything. The Environmental Control and Life Support System reclaims water from breath, sweat, condensation, and even urine. Advanced filtration and distillation make recycled water purer than most tap water on Earth. Today's coffee is tomorrow's coffee. Nothing goes to waste. This closed-loop system allows crews to stay in space longer and reduces costly resupply missions. Perfecting water recycling on the ISS is vital for future missions to the Moon and Mars. Long-duration crews will need to be self-sufficient, relying on these life support systems. The lessons learned in orbit are shaping the technology for humanity's next steps. Sustainable living in space starts with mastering water recycling. The ISS is our test bed for survival beyond Earth. In space, water behaves in mesmerizing ways. Without gravity, surface tension pulls water into perfect floating spheres. Astronauts play with these blobs, watching them wobble, drift, and even swallow objects. It's a beautiful demonstration of physics you can't see on Earth. But it also brings challenges. Spilled droplets can float into electronics and cause problems. That's why drinks are in sealed bags with straws, and hygiene routines use minimal water. Even tears behave differently, clinging to eyes instead of falling. Every action with liquids requires care and precision. These experiences highlight how much we rely on gravity in daily life. Water's zero-G dance is both a source of wonder and a constant lesson in adaptation. Living in space means relearning the basics. Watching water in orbit reminds us we're in a truly alien environment. It's a daily reminder of the marvels and challenges of life beyond Earth. Water in space isn't just for drinking. It could revolutionize exploration. Split into hydrogen and oxygen, water becomes the most powerful rocket fuel we know. If we can mine water on the Moon or asteroids, we could refuel spacecraft far from Earth. This concept, called in situ resource utilization, means living off the land. Rockets could launch lighter, refuel in space, and travel farther for less cost. Lunar mining bases could process ice into water, then split it into fuel and breathable oxygen. Solar-powered electrolysis would turn water into liquid hydrogen and oxygen for storage. This would make deep space travel more affordable and sustainable. Water also supports agriculture and life support, reducing what we must bring from Earth. Accessing space water is the key to permanent outposts and true exploration. It transforms us from visitors to inhabitants of the solar system. Water is the resource that unlocks our future in space. The story of water in space is the story of our future. Water has always sustained explorers. Now it will sustain us beyond Earth. Discoveries of water on the Moon, Mars, and icy moons have turned distant worlds into real possibilities. Water makes permanent bases and long-term missions feasible. The quest for water drives new technology, mining, recycling, and life support systems. These advances will benefit both space explorers and people on Earth. Becoming a multi-planetary species may be essential for humanity's survival. Spreading into the solar system is the ultimate insurance policy for our species. And it all starts with the search for water. The trail of water is the path to the stars. Our journey to become citizens of the solar system begins with this simple, vital molecule,